Hello and welcome to Pumping Python. My name is Jacob Itegbuje. Here I'm going to show you how I set up a test-driven development environment. First, make sure you have test-driven development is a way of developing software with a focus on tests, where we come up with ideas to reach a goal. We test them. The results of these tests tell us if we're closer or further away from the goal. We repeat the process until we reach the goal. I learned test-driven development from reading Ken Beck's Test-Driven Development by Example and Martin Fowler's Refactoring. They both influenced me in a great way. Here is a way to set up a test-driven development environment for Python projects. First, make sure you have Python. You can go to python.org and download a version of Python. Then make sure you have an interactive development environment. You can use one in a browser, like VS Code in a browser, or you could download VS Code for your operating system. Doesn't matter which one you use, just select from here. If you don't have one, you could also use PyCharm if you want. You can use Sublime. There are a few options, or any of the options listed on the Python wiki, or you could just do a Google search for one. Doesn't matter, as long as you have one, you should be good. I use VS Code, that's my preference. If you're on a Windows machine, make sure you download and install Git, then install WSL, and you can run these same commands I'm running in WSL. Let's set up a file structure for the project. First, I'm going to open a terminal in my IDE, and this is wrong. First, I'm going to open a terminal on my IDE, and then I'm going to create the directory structure. I'm going to name this project name. You can name it anything you want. Project name is just a placeholder. I say mkdir-p project name / test. It's going to create a folder named project name, and inside that folder, I'll create a project named tests. And you can see project name and then tests. And then I change directory to the project name so that I can work inside of that folder. This folder is going to contain everything we do, our dependencies, our source code, and our tests. I'm going to use touch to make an empty file with the names of the files that I need. So project name.py, which is the name of the thing we're writing. It's going to contain the actual source code. I'm going to add a __ init.py to the test folder to tell Python that, hey, this test folder is a module, so you can read it. And then the actual test file will be test project name.py. That's where we're going to write our tests. The folder structure should look the same as mine. Project name, test with two files inside the test folder, and the project name.py. The test-driven development cycle paraphrase is red, green, refactor. Red, make it fail. You write a failing test to make sure the test works. Green, make it pass. Write only the code necessary to make the test pass. Refactor, make it better. Let's make it fail. We're ready to begin writing our first test. Open up tests, test project name.py, and I write import unit test. Unit test is a Python module from the standard library for testing code. Class test project name. This creates a class. If you don't know what that means just yet, don't worry, we cover that in a later time. And it inherits from unit test of test case. Test case is another class inside the unit test module, which has a bunch of methods or functions that we can use for testing. So my test project name class inherits from unit test of test case. When I say something inherits, it means that test project name is a child of unit test or test case or copy, so it can do the same things that unit test or test case can do. I add a failure test because I want to see the thing fail. Say self.assert false, and I say true. This means def is the keyword for creating functions, so test failure is a function. I pass in self. Self refers to test project name. So this thing can refer to itself, which means I now have access to the methods of unit test or test case. I can say self.assert false. Assert false is a function that takes in an input and checks if that expression is false, as you can see in the explanation here. So I pass in true to see if true is false. We know true is not false, and so we're expecting an error. To test the code, I say Python 3-m unit test. This is the version of Python that we're using. -m is an option that says, hey, use this module that I gave you after to run that module. When you run the unit test module, it's going to run this code. We get a response in the terminal. telling us that there's an error. Congratulations, you've written your first test. Reading the error, I like to read it from the bottom up. That gives me a good clue of what's going on. Failed, there's one failure. I ran a test in negligible time. It's less than a second. Assertion error, true is not false. That was expected. An assertion error is raised when an assert statement is false. So in this case, there's an assert true is false, and it turns out that true is not false, so it raised an error. This shows us the line of code that made the error. And then right above it is the address or the location of the failure. This shows you the path on my computer where the failure occurred with the line number where it occurred. I'm on a Mac, so if I hit Option and I click on it, it's going to take me to that position in the ID. If you're on a Windows or Linux, you hit Control and click, it will show you the same thing. Traceback is everything that happened. It just shows you what steps it took before you go to the error, showing the most recent call last. That's why I read from the bottom up. And then fail, test failure, is telling you the function or the method that failed and where it is. So test is the test folder, test project name is test project name.py, test project name in title case is the name of the class on line 4, and test failure is the name of the function on line 6. And then F showing that as a failure. To make it pass, I change this to false, and I run the test again, and there you have it. One test, same negligible time, but things are okay now. We are green. The third part of the test-driven development cycle is refactor. We can make code better, just to make it better. We can make code better by using the abstraction principle or the do not repeat yourself principle. Both of these can be summed up as remove duplication. In the actual code that we've written, there's not much to improve, but there has been duplication. So far, I've written Python 3-m unit test twice. And if I make a change, I'm going to run it again, or if I add a test, I'm going to run it again. This means that for every part of the cycle, I am going to write Python 3-m unit test. To avoid this repetition and focus on tests and solutions, I automate the repeating part so I do not repeat myself. Here's how to automatically run tests. First, we need to create a virtual environment, and I'm going to create a requirements file that will hold my dependencies. I'm going to use the PyTestWatch library. This library will watch my folder and run tests for me. So I created requirements.txt and PyTest-watch to the library. Then I create a virtual environment. So doing the same thing we did, or a similar thing, Python 3-m. I give it VNV as a module in the Python standard library, and I give it the name of the virtual environment. In this case, it's .vnv. You can name it anything you want. It's going to create a .vnv folder. That's where all our dependents will be stored in an isolated subfolder. To activate it, I say .vnv/bin/activate, and you'll see a .vnv on the left-hand side of your terminal, which tells you the virtual environment is activated. After activating it, I'm going to upgrade pip, which is the Python package manager, by saying python-m pip install upgrade pip. I'll upgrade pip to the latest version, and then I say Python 3-m pip install requirements.txt. That's going to install PyTestWatch, and I can use PyTestWatch to automatically run tests when I make a change. It's done installing. I say PyTest-watch. I'll automatically run my test. Says one test passed. To prove that it's actually monitoring the file, I change it to true. We're expecting a failure when I say true. And sure enough, assertion error true is not false, with the location of the test, with a summary. Test project name of the test failure shows you where it failed, shows you the line, and same, you can option click this and it takes you to the position where it failed. Congratulations, you now know how to write a test and automatically run it. If I want to get out of the test, I just hit Control-C in the terminal, and I can deactivate the virtual environment by typing deactivate. If I want to activate it, remember source.vnv/bin/activate. All right, now here's a bonus for you. you can automatically create a Python test-driven development environment. You made it this far, you become the greatest programmer in the world. Following the practice of removing duplication, I would write a program that contains all the steps above. So I'm following the do not repeat yourself principle. I can then call that program anytime I want to set up a test-driven development environment instead of manually repeating each step of the process. So there's a bunch of things we did to set up this stuff. If I have to do this every time, it's best for me to write a program that I call once and it does it. Let's write the program. I go cd dot to get out of the project name folder, and then I'm going to type history in my terminal so that I can see all the commands that I wrote. Starting from the beginning, we had, see, project name, touch this, touch, all of that stuff. So that's a reference for me to use to create this program. I'm going to call the program setup TDD Python, setup Python TDD.sh. You can name it anything you want, just make sure it's something you remember. So I say setup Python, touch setup Python td.sh, and then I copy all the code that I used to create this thing. And remember, the first thing we did was mkdir, the project name. So I say mkdir-p, project name / tests. Need to remove all these line numbers because we don't need them. Oops. All right, now the problem with this is project name is fixed. So I need to make this variable so that I can pass in any name and it will do the right thing. So I do that by saying project name as a variable, $1. This now means that whatever I give this program will be, whatever name I type after the program will be the name of the project. Change all the places where it's fixed as project name so that they become variable. Project name.py, test project name. All right, almost done. Last step is to write the code that goes into test project name.py so that I can have the code automatically run. To do that, I use the concat program. Say cat hashtag, no hashtag, two arrows, delimiter. I can spell that correctly. I say delimiter on the bottom. Just tell the program that anything between delimiter and delimiter should be added to this file. So import unit test, class test, $project name, unit test, test case, define test failure, self.assert false, true. Now, one more step, I have to make this executable. So I say chmod +x, which means make this file executable. And then I can call it setup python tdd.sh for any project. Let's say I want to create a project named Magic. I do that. Say it creates Magic and it automatically runs the test. So if we look at the Magic folder, we'll see it's got the same structure as project name. We got a .venv, we've got tests, we've got the name of the project as a .py. Inside the test folder, we have an init.py, we have test_magic.py, like we have test_project name.py. And when I do test magic, I see self.assert false. If I change that to false, I should get green in the terminal. Congratulations. This is one of the advantages of programming. We can take a series of steps and make them a one-line command, which the computer does on our behalf. There you have it. You now know one way to set up a test-driven development environment for Python projects and have a program to do it for you anytime you want. Happy trails. See you in the next one.